Hello, today we will be solving conversion sorted list into binary tree. But first, I would like to solve this one, which is easy problem. It converts sorted array to binary search tree, and conversion is pretty simple because we have a list sorted. It will go with in order DFS started from middle node. So first we will create DFS. We accept root node, and then what we're gonna do, we're gonna accept lists, right? List, and let's call it all. So first we're gonna find middle, which is len of L deleted by 2. Then we create node as 3 node, right? 3 node with value as L mean. Oh, let's call this array. It will be better because it's array, right? So we create array mean, and then right value will be is it right or is it left? So everything that on the right side, everything that on the left side will be DFS with array from mid. Everything on the right will be DFS goes from, oh, I think it's different. It's like this. From mid to end. From mid to end. This is start and step. So it will be start. It will be start, no end. And mid will be end, and we return node. And we return whatever we can call from DFS root. Nums? No, nums, sorry. So yeah, basically that's it. It's very simple thing, but we have, do we have to do like -1 here? Index out of range. So array. So let's print it. Okay, so we have to say if need more than 0. Okay, so what is wrong with the thing? Because me. should I say if array? And otherwise else we to none. Maximum recursion. Okay, so if array, let's print int. What is wrong with this? Oh, this is 0, 0, 0. I think we have to return from the right plus 1. Oh, because of printing? Yeah. Because of printing. I'm also not sure if we have to do -1 here. And speed is not good because I'm copying array every time. So that's the problem. So I will have to solve it with better. So I have to solve 108 with indexes instead of array, because right, so for example, if you're passing array, but can we to have a better performance, we have to pass indexes begin and like, for example, begin end, and here we midpoint will be begin plus end minus begin divided by 2, and then we call DFS, we pass same array, but begin will be 0 and end will be midpoint. And here we pass an array, begin will be and end will be endpoint that we got, right? And we pass as 0 and then as, oh, we can also declare all as the length of nums, and we pass big L, and here we can say, yep, parent is does not, okay, DFS begin, oh yeah, I don't have to do this. But is this gonna be 0 or is this gonna be begin to need? I think from begin to need, and from need plus 1 to n. maximum recursion. So we array will be always array, right? So we have to consider if and minus beginning more than 0. Yep. Slightly better, like 26%, but still not good. Why? I wonder why. This is because of calling internal function. Okay, it doesn't matter. I think it could be some internal LeetCode thing. Let's switch back to another one, which we have to work with sorted list. So this will be the same. So the same problem, right? So we will have a list, and we call we're gonna have the same DFS problem that we accept root. However, here it will find a midpoint from the root. But not only midpoint, we also need to find a left. Let's call it like so. We not only need this function for us to return midpoint, but also need to return no, midpoint should be enough, right? So we got midpoint, which is m, for example. Then we will call new node as list node. Oh no, tree node. Tree node with midpoint value, right? So list node is val, midpoint val, and this node we also have to check the same thing, right? We have to have if root, we do this, or we can say if not root return none, then we then end because this is in order traversal, so we assign left everything left first with everything that we have in root. But I shouldn't call it root. This is not a root. This is beginning of the list. So let's call it beginning of the list. Also, here we have to split a list. So when we assign, when before returning mid, we change previous node next to null. Okay, so we're gonna have another function. I will call it mid, and it will accept head or beginning of the list, right? Beginning of the list, and this is what our function will do. Let's move this into here. We have to split list before returning mid. We change previous to null, right? Here we go and we return m, and we also at this point list is splitted into two. So first will be DFS head or beginning bang. Then, so this is will be first part of the list, and this is will be second part of the list started from right will be DFS middle point next, right? Because we are not accepting middle point. And then we return a node. And here we call return DFS head. Now we have to code mid, and for that we assign slow and fast pointer pointing to beginning, and we have to do while f next and f next. What we're gonna do, we're gonna assign s equal s next, and we also need to find define previous, which will be none, and here we assign previous equals slow. So previous will be pointing on next element. But for example, for this list, right, when we have midpoint as 0, p, which is previous, will be pointing on -3, and we need it to assign at the end p next to null. This is why we need it. And fast equal fast next, and before returning slow, which is we assign p next to none. So we split list into two, right? Looking good. So previous was none. Why? Oh, because there was nothing in here. Should I assign it to beginning as well? Okay, let's give it as a beginning. I don't know. It's probably something that it's not working. Maximum recursion, yes. So if not beginning, return none, 3 node. So we're trying to find the need of the beginning, but if let's print value of node, beginning node, right? Because what if we have a none here, right? If we have a none, we return none. We have a p next none as a none. Okay, let's see. I believe there is something wrong with this pointer, and minus 10. Okay, minus 10. So it's stuck. Okay, so something minus 10 and 0, and we return in 0. But then when we got minus 10 and minus 3, right, we always return minus 3. So my question is, we always return minus 10 as a middle part. So between minus 10 and minus 3, yeah, so first we returned, what if we have a 2? If we have a 2, what is midpoint? Let's say midpoint will be minus 10. Okay, we return minus 10. Then we assign minus 10 to 0, 0, and previous minus 10 none to, oh, we assign minus 10 next to 0. And then we call, then we assign from, we use beginning pointer again. So see, we pass minus 10 here, and we decided like this part, minus 10 and minus 3. The result is minus 10 with cut off minus 3. So minus 3 will never be back. Right. Yeah, so maximum recursion. That object. Okay. So that means that we are returning midpoint as 0, right? Then we call in from beginning and we go into -10 and -3 doesn't have end. So what we should return? We return -10 as an end. What should be mid node here? Let's say if mid node is -10, then we cut connection, we return -10, and this is just only node. So I would say if this is the only node, should we return it? So if I say if next, see, so if we return we got recursion in this case, yeah. So if we return none, but we have to return -10, right? Again, if this is just one node, we assign it, and we will call again with -10 again. That's the problem. But if we return -3 as the middle part, and -10 as the previous, we assign -3 to the left. Okay, so we can say if not. We can say that previous next. No, we cannot assign it because we have to return it again. That's the problem. Yep. Okay, let's ask ChatGPT about this. Is not updated. Okay, if big next is none. Oh, interesting. So what is the return? Helper function find middle of the list and split it. Okay, base case list. But left list. So it has to return left list. Okay, we're disconnecting it. So we have to return left list after splitting. Single element in the list, no left subtree. Can we G code without helper function? So the idea of creating mid function is could be not good. See how the I don't know, tree node. Oh, it's calling the same. It's kind of less code, and because I don't like the idea of returning two values, like beginning, middle, list. So beginning will be whatever we received. Why we returning it back? I don't know. Return back none. Return stolen back. Because we need to assign none here. If not back or back next. Okay, so into 2, and we return middle point, and we have here none. So we are disconnecting. Disconnecting, yes. Not. And we are assigning p next if only previous existed. Okay, if previous existed, we assign it here. And we returning middle and left. So if beginning equal middle, we return root. Okay. But why we return left list? We are not doing any, oh, we assign left everything that we got in left. Okay, makes sense. And here we assign everything from middle next. And we also have to say if begin equal middle, we return begin. See, it's too many corner cases. It's too maximum recursion. So we have a 3 node left, but it's not, it's left, right? No, it's left 3 node, DFS left. 3 node middle value. Right? If beginning equal middle, we return beginning. Still maximum recursion. Okay. Oh, we just return. So here we just return node if this is one node. Otherwise, we call left from left side, and we call from mid node, and we return node. Okay, this is insane, bro. So we got middle node and left node, and we create node from middle. So here we cut off previous as well. But we assign previous to slow right away, so it doesn't matter if previous, then we assign return slow and the beginning. Yes. If not beginning or not beginning next, return beginning unknown. So beginning, if not beginning value that we received, we call need, we create root node, we return root. Yes, this is much shorter. It also have a previous node. Um, use, station, solution. This is crazy. Okay, yeah, I think I'm out of time here, but definitely um, I have to take a look why it's not working. If we have we assign we got midpoint, we create node, and however if beginning and equal middle, we return node. So here if beginning equal middle, we just return nodes that we created. If not, beginning return none. We got 3 nodes from val if beginning equal middle. We return the code DFL left, we call what we got from left. And here we from mid node next, and then we return see, but the thing is that there is a different thing here, and that could be my major problem. %, not bad. However, yeah, I would definitely have to do. I kind of like it with a function because I'm not calling the main function again, but should I call the main function? As this code is good, like original one, who is calling most efficient without helper function. It's kind of short and clean, right? One node, perfect, simple and clean. Then we got, okay, code, fast next, previous assign, we create node, and then we call it again with head and slow next. And that's it. I really like this code, and I will try next time to solve it with this code, or maybe with a function as well. I really like function because I was trying to encapsulate finding middle point somehow. However, the thing is that it's not that simple. Like, what if you have a 2 points? What is the middle? We have to return middle as a slow, which is this one. But then we have to return none, right? If not beginning, if not beginning next, if there is a not beginning next. It's just simple, just one node, right? So we just return none. But if there are 2 nodes, what we are returning? So ff next, and we assign as next. So we return in -3 this in this case. So I can say that we received right, and then I can say we returned this guy. So we received -10 and we return 0. We received -10 and we return -3. Oh, this is the case. We return -3. Not -10. And that was the whole thing. All right, it's still good. It's still good. I learned a lot. I tried to do it right away without like all edge cases and all these situations that can happen. And yeah, I got run into problems, but they're very good. It's all practice. It's all. I most definitely have to solve it again, and I will solve it again, and probably post a link on it. But I really like my approach to as with encapsulation of the function, and I really like calling the same function again too, because it does look good. That look good. All right, that's it for today. Thank you for watching. See you next time. Bye.